In this video we will look at another example for multi-loop circuits. So we will first choose the direction of current. So look at the circuit. We have taken I1, I2 and I3. We have chosen the direction of current. That means it's up to us how we decide the direction of current. Don't have to worry about the values, because the values, if they come negative, that indicates that the direction of current should be opposite to what you assumed. Second step, we will first apply the junction rule at C. So I1 plus I2 minus I3 is equal to 0. I1 and I2 are entering into the junction, so they are positive. I3 is leaving the junction, so it is negative. Third step, we apply the loop rule. There are 3 loops: A, B, C, D, A, B, E, F, C, B, A, E, F, D, A. We are going to choose the first 2 loops, which is highlighted. Next step, we are going to look at the loop direction. We are going to choose clockwise loop direction. So again, as I have told you before, there are 2 directions which we are looking at. One is the current direction and one is the loop direction. Now for both the loops A, B, C, D, A and B, E, F, C, B, I'm going to take clockwise direction for this video. Before applying the rule, we have to decide the positive and negative for each component. So you can check. For the cells, it's easy. There is no need to worry about the positive and negative of the cell. We know the longer line is positive, the shorter line is negative. For the resistors, if we check the 2 ohm resistor, the current is moving in this direction. So conventional direction of current is from positive to negative. That's how we have labeled the positive and negative. Similarly, if we look at 6 ohm, then the current is moving in this direction. So we are taking this side as positive and this side as negative. Okay. Now the last one, for 4 ohm, current is moving upwards. So down is positive and up is negative. So by this time you should know how to get the positive and negative for each component before we go ahead and apply the loop rule. Now we are going to take the first loop A, B, C, D, A. You can check how we are writing the equation. For AB, there is no component, so 0. For BC, there are 2 components. So for cell, we reach the positive 10. For the resistor, we reach negative of the potential difference, by which is by Ohm's law of IR. So in this case, it is I1 multiplied by 6. For DA, for CD, there is no component. Check the circuit, there is no component in CD. This is the part which we are talking about. There is no component in CD, so we write it as 0. For DA, there is 1 component, and we are going to, when we cross the resistor, we are reaching negative, so that's why we are writing negative I3 multiplied by 2. Now how do we get this I3? How do we know that it's I3 in the 2 ohm resistor? Just check the current. This is I3 which we had labeled before. This same current is going to go through 2 ohm. So the current through 2 ohm is I3. Okay, now we are going to simplify the equation. We get the first equation, then we go ahead and do the same for the next loop. So for BE, we can check from the circuit. For this section BE, we are going to reach negative side of the resistor, so we write negative 4I2. For EF, we are going to reach negative side of the cell, so negative 14. For FC, there is no component, so we write 0. For CB, there are 2 components. For the resistor, we are going to reach the positive, so 6I1. It's positive 6I1, and for the cell it is negative 10. So now we simplify this equation. We combine the numbers and we get the third equation. So we have got three equations. We are going to rewrite the three equations once again. I1 plus I2 minus I3 equal to 0. 10 minus 6I1 minus 2I3 equal to 0. Minus 4I2 plus 6I1 minus 24 equal to 0. We have got three equations. Now from equation 1, I3 can be written as I1 plus I2, which we are going to substitute in equation 2. You can check in equation 2 we have got I3, so we are going to write it as I1 plus I2. We can open the bracket, simplify. Then we are going to solve equation 3 and 4. You can check equation 3 and 4 can be solved simultaneously for I1 and I2. Get the value of I2 and I1. Once you get the value of I2 and I1, I3 is I1 plus I2. So you can substitute the values, you get the answer.